16 mil. So what you see in front of me is a magnetostatic power charger. And just an overview of our general parts. We have our power supply, a 100-watt amplifier, our transceiver circuit, which is basically a bank of capacitors, our transmission loop, or inductor, our receiver inductor, and our receiver circuit, which is basically a bank of capacitors, a bridge rectifier, a 5-volt regulator, a bank of filtering caps, and a USB output port, which is going to charge our target device. And have a few test leads connected for demonstration purposes. And here we're going to turn frequency on. This is the main driving force behind this project. And this is what drives the resonance on the circuit. You can see we're at 8.5 hertz, 8.5 kilohertz. I'm going to power our target device, and the same screen is on multimeter. And I'm going to start turning up our volume, which will energize our loop. So increasing. So we're at 30 volts on the transceiver side. And as we pass forward, you'll see our target device start to charge. It's starting to charge now, slowly. We're going to continue to increase our transceiver side voltage to just under 100. There it goes. So here we're at 95 volts. Now we can't really go over 100 volts because of these output capacitors on our audio amplifier, which are capped at 100 volts. So we don't want to trigger the thermal protection. Here you can see our device charging. And I'm going to show you what our receiver side voltage is. I'm going to switch over the leads. I'm going to connect. DC. And here you can see our USB device is charging at about 4.65 volts, which is a little bit below the 5 volts we want to charge our 5-volt device. Now initially we had this larger loop that we're using to charge the device with, and we thought that if we used a smaller loop, that the flux density would increase and the field would be more concentrated towards our receiver loop. That was not the case, and our voltage still remains below 5. It didn't really improve much. Now we can change the frequency, and you can see the change in the output voltage, which we're going to do just now. Now we're at 8.6 kilohertz, and notice our voltage dropped a little bit, and going the other way. Turn this down a bit. Our voltage dropped a bit there too, compared to what we had before. And return to our original value of 8.5 kilohertz. Still capped in relatively the same area, around 4.6 volts. Now we have a couple of potential solutions to this problem. One, we can try to build an alternative coil, which is somewhat like this here, which is a flat design rather than a stacked design. And this would increase our field area. Another thing we're looking at was using operational amplifiers to increase the current in our transducer loop. If we use an operational amplifier and increase the current, we can also increase the magnetic flux in the transceiver side. And that would also aid in transmitting power to the receiver side. We also had the third idea of using a Darlington pair to increase the current on the transmitter side, which would also aid in our power transmission and receiving on the receiver side. And our current, which is our target area of interest here, currently at about 3 amps here on the transmitter side. And this is our area of interest that we want to look at to increase to aid in our power transmission. Another area that might be worrisome in the future is our audio amplifier here. I know it doesn't look that way, but this thing's running pretty hot. It's quite hot to the touch. In just a second, I'll show you. Our transceiver loop is also pretty warm. Probably close to 100 degrees Fahrenheit. Alright, here we have our heat gun. As you can see, our audio amplifier here. About 204 degrees Fahrenheit, which is really hot. And that's one area we're looking to reduce the heat there, because as I'm sure, that would definitely lead to circuit failure. This is our transceiver, our receiver circuit. Our receiver circuit's around 92 degrees, so it's not too bad. A little warmer than the environment, the ambient, but it's not too far off. And here's our transceiver circuit capacitors, which is also pretty warm, about 110 degrees Fahrenheit. And our inductive loops, which aren't too bad. They look to be about in the low 90s, so a little warmer than the environment, but not too bad compared to our power amplifier, which is blazing hot right now.